Så. Det ser ut som det börjar trilla in lite folk på konferensen. Så välkomna allihop.
English, Magnus, English.
In English, sorry. Yeah, I see that some people entering the conference now, and so you're all welcome to visit our little eBazaar today. I will be a little slow here initially to make sure that everybody's getting their seats in the room virtually. So I also want the attendees kindly to disconnect the video, because that will help us to run this smoother. That would be great. My name is Magnus Melander, and some of you know me already and some probably don't. I've spent quite a lot of years in the business. I've done 20 years in American IT companies. I've built a VC. I've been on my own for a while, and nowadays started and co-founded things together with Lindgren, who is the technical supporter behind all of this here. And I also work in a couple of startups in the field as well. So things, unless you know things, we started things on one single idea that Sweden lives out of industries. We live out of forest, mining, and water, basically. And we just have to make sure that our industry continue to prosper also after the digital transformation. So our idea was to bring corporates together with innovative startups relevant for industries, physical things, and try together to learn how to transform innovation in smaller companies to value creation in large. We've done that for 6 years now, and we are quite many companies involved in this now. We are typically 120 or so smaller companies who are members or have been members over the years. And we have about 45 corporates who are members. We call it Things Enterprise Circle, is where the corporates have their membership. And the Things Enterprise Circle member, first of all, they get invitations to all spectacular things we do together, all the events and activities. We also give them access to the house, so you can actually go there and have meetings there and so forth. But we also have a small a la carte list of services that we can offer them, including things like organizing workshops or challenges for them. And we also help them arrange their own specific customized events. They can build their event to run them on things and so forth. 1/3 of the companies are international, basically, and 2/3 are Swedish. So having said all of that, I would love to ask you questions, but I will not do that. We can take that offline, I guess. Now when we were struck hard by the COVID-19 problem, we immediately decided to move all our events online, which made stubborn old men like me to have to learn a lot of things, how to manage and master all those technologies and things. It feels a little bit like working on CNN or something like that, when you have screens everywhere and so forth. So I'll do my best to do that. We also decided to focus all our efforts these days on the smaller companies to try to help them fill up the sales funnels. Because for most of them, the projects that were ongoing, the larger companies basically was halted or paused or at least slowed down. And it's very hard to make new businesses and deals right now. It might be hard to meet each other. So we thought the best value we can offer is to help put them in contact in an organized way with new large enterprises companies. And that's why we created this little format we call eBazaars. You know, when you enter a bazaar somewhere, people are screaming on you, buy my toy, my soap, buy my this, buy my that. This is a little bit more organized. We only have 6 companies who are going to scream on you. We always pick a topic, so it's only soap or shoes that they sell. And this is our second event. Each company will present for 15 minutes, including the Q&A, and which means that this is 1.5 hours for you to listen. And then afterwards, we will send out a post-event email to each of the attendees, including the contact details of the presenters and also a request for feedback and so forth from you. So I will moderate this event today, and we kindly ask you to raise questions if you have them using the chat system, which is down in the bottom of your screen. We also would like to point out that we film all those events, which is obviously not true because we don't have a film camera, but there's a feature in Zoom where you can save the entire conference. So that's what I'm referring to. And we're going to use that in different ways, in different channels that we use. We will probably, if things works out well, we'll probably have the entire event on our YouTube channel, for instance. So this means that for speakers specifically, you have to make sure you don't say things you don't want to have on film, or do things that you don't want to have on film. We also ask you all to be on mute, because it's easy to blur a conference like this if there's too many noises here and there. And I'll do my best to make sure that we stick to time. So without any further ado, I would like to hand over the screen to our first speaker, which is Gustaf Lagercrantz from Gemit.
Thank you very much.
Please share a screen and get going.
Yeah, thanks a lot. Thank you, Magnus. And someone else is share now. Good, thanks. There. I hope you all can see my screen now. Yeah, my name is Gustaf Lagercrantz. I'm from Gemit Solutions. I'll be talking a bit about what we're doing in the smart utility sector, which is our focus area. Oh. There. I listed a number of our customers and also one of our partners. And those of you from Sweden, you'll detect that these are in the public sector, and it's within the water, drinking water and wastewater treatment area we're working with. I'll be talking about what we're doing with them and how they're leveraging our technology in getting it smarter and developing their business. We also have a partnership with Fleer, where we had a combined solution with their thermal cameras and our platform to help customers detect deviations in their production, etc. But smart utilities, we're right now working a lot in this sector, although we're having discussions with others as our platform is generic. To put it in a context, what our customers are doing, if we start from the bottom left, is industrial sensors. In this scenario, it's water pumps, flow meters, different types of equipment they have in their system. In addition to that, they have from SMHI in Sweden, weather forecasts that affects their line of business. The electrical market is another area which is important to them, as a lot of the equipment consumes a lot of energy, and sometimes they can control what time of day they run certain pumps, for example, and then that's valuable. As they're also running a process where quality of water in both sewage water and drinking water is important to keep control of. They do a lot of sampling and lab tests, and that's feeding into the process as well. There's all kinds of arbitrary events going on and a lot of maintenance activities, both out in the grid in terms of the pipes and for drinking and sewage water. And there's also a lot of IoT devices out there in the grid. I won't go into that. I'll leave that for Kalle. We've done some stuff with them from Sigfox, so I'll let him talk more about that in this area. But within the circle, then, once we get hold of all the data, we're helping them with reporting. I'll come back to why that's an issue in this line of industry. Soft sensors. They're combining different data. They're getting into soft sensors to create alerts, have real-time alerts, and clean the data in order to then work on with machine learning where data quality is important. From an analytics point of view, they want to see trends in terms of quality of samples from like nitrate or different types of quality of water, and do annotations. And what our most advanced customers who are now moving in or starting to move into machine learning, they're also looking into the part of digital twin, where they need to feed in data to a digital twin of their plants. So that's where we're heading. To put us in context, this is a triangle in our area or part of the industry. You'll have the production process, the flow of, say, sewage water. And that process has a number of sensors, whether it's pumps or flow meters or what have you, that generate signals, or the PLC controlling the pumps and the SCADA system, or multiple SCADA systems controlling and running in the operations. On top of that, that's where we come in with the manufacturing execution system and generate, help them tap into their data streams they already have there and generate value. And I'll have some examples from one of our customers pointing out to how they're enhancing or increasing their efficiency by 90% in reporting, and having been able to optimize their production processes by 50%. So how do you go about this? There are essentially 4 steps we typically work with our customers on. It's from data collection to have data to work on, the reporting, analytics / optimization, and finally automation and machine learning. So if we start with data collection, there's a lot of data generated in this process. The problem is, it's not the amount of data. The problem is it's spread out. You can't see the forest for all the trees. It's spread across different types of vendors. There's different types of SCADA installations, different types of versions. And as this is a public sector, every time they purchase something, they do a public tender, and many times they get a new vendor for each purchase. So if you compare to like the private sector, where you can run a standardization project, it's not as easy in this line of business. So what they're stuck with is an overall process that runs as a whole, but the data does not. I mean, on system level, they have either and some of our customers have up to 5 SCADA installations, for example, where you typically only want one. They'll have then from different vendors, they'll have different versions of systems. The data that they receive is in CSV format or some proprietary format, etc. It's more or less documented, so they have issues there. The data they're getting then is either in real time, but it can also be updated in seconds, minutes, hourly, or per day, which makes it also more difficult for them to manage. Our approach to this is not perhaps the traditional to build a data lake, etc. What we do is we read from the source systems. We only have read writes, which is another important from a security aspect, as this is critical to society, and security is always important to our customers. So we only read from the source systems, and we don't sort of build a huge infrastructure project to build a data lake. We also have off-the-shelf SCADA adapters to SCADA systems, LIMS systems, etc. Because there's a limited number of vendors, and well, we've seen them, more or less all of them. Sometimes we also see homegrown systems, but we have an architecture that helps us integrate easily to this. And once they have the data, well, then there's a matter of reporting. And of course, this is from one of our customers, Spahr, handling large parts of the Stockholm sewage water, etc. This is from the internal website, where they're producing and presenting live data on how much biogas they're producing, heat, nutrition, what the flows are, etc. And before they start to work with the system as ours or something similar, the approach, and this is quite common still, is they do this manually. And they need to connect to all the different systems and extract the data, which is time consuming. It's not only one person who can do it typically. You need to involve multiple people. So it's resource intensive, and every report is more or less a project. Of course, it's flexible. You have short decision paths that you can do within your department. If you start to involve IT, well, of course, you typically have like an integration project. You buy some IT platform, which increases your IT infrastructure costs. And then you can build the applications on top of that. But you typically need additional training and specialists to work on it. You get structure, control, but it's typically not your everyday operations tool. It's more reporting like. So those are the alternatives they've been working on. And the question then is, well, how important is reporting? Well, in this line of business, there's moving back like over the last 5 to 10 years, there's an increasing demand on reports, both governmental reports, but also voluntarily reports for agencies within Sweden for for quality of water, amounts of water produced, etc. But then there's also the internal ones for production management, KPI, etc. And this is going on over and over again, each year, every month, week, and it's always more or less a project for them. The question then is, they tie up the resources to work on reporting instead of looking at the next part, which is analytics and optimization. What you see is actually here is a screenshot from the tool where perhaps a process engineer who's very familiar with the processes looking at the different parts of the data, which he here has at the top of his hand. Once he has that, then you can start to look at it from different perspectives. The top right corner there, you'll see a yellow marked area. That's actually a pump that fails. So what they were able to do with our data was to, okay, going back, could we have detected this in some way and set alerts on that? And they discovered that 21 days before this failure occurred, they could actually see this trend. So they have now put in alerts or soft sensors that triggers this. So they can have an alert if a pump starts to fail, for example, so it can do proactive maintenance or predictive maintenance even by using soft sensors, using the data they already have, but they can have access to it and they're able to analyze it swiftly. It's also used for dimensioning purposes, for example. We have an example from one of our customers who after just having started with the system, deducted that, okay, we could have used this information to dimension one of our pump stations and reduce the capacity on that pump by a large factor and saving a lot of money. So that's another area they use it. But typically you don't get here unless you're using a solution like this. Once you reach this part, then you can move on to automation and also machine learning, for example. As I mentioned, either you start with the looking at the trends, the graphs. An experienced user can do a lot by just looking at the graphs and visualize the data. From there, you can also take the next step, which is rule-based soft sensors, like the pump I mentioned earlier. So you can build up your own catalog of rule-based soft sensors that sends you alerts adapted to your infrastructure. In this grid with multiple sensors and so on, as a human factor, it's hard many times to keep in mind multiple sensors. So if you have, say, 10, 15, 20 different sensors that are interdependent, well, then maybe you need to apply machine learning technologies to deduct this. So, well, we've implemented these tools in the product, so the customers can train and create their models directly in the model, having access to the data, which is cleaned up for them. So when you start to apply this, what are the effects you see from this? And one of our customers has started to share data on this and what this actually means. And reporting, as I mentioned earlier, is one part. And there are all these types of reports, and these are their own that they have to do every year. And they were able to compare over a 10-year period. The first 5 years, they did this manually, more or less. They were a bit more sophisticated, but after the last 5 years, they've been working together with us and have been able to conclude how much time they've saved. So they've gone from 746 hours to down to 50 hours, which is huge saving for them. But the effect from that is that once you have free up this time and visibility, well, then you can save more time to work on your development projects, enhancing the process. And also there, just collecting data for this type of projects, they moved from 200 to 0 in terms of saving, because the data was already available. You didn't have to go around and talk to different parts or organizations, getting access to data to make a decision. So the consequence of this is, one, they're freeing up critical resources because it just was the specialists have to create these reports. So they free up resources. They also have data available, so they can make decisions based on data. So they could also then compare, okay, what was the effects on the organization and our rate of improvement? And now it starts to get exciting, because they moved from improvements of on an annual level of 1 to 1.5 million SEK per year. They were able to double that with a combination of freeing up resources and also having availability to the data, access to the data much easier. They were able to double that and increase the savings additionally. So that's sort of the effect, starting from taking away something a bit boring like reporting And the consequence has actually been that instead of doing less reporting, they do more reports in less time and have more effects from them, which is powerful in their respect. And if you took them, the different types of on a maturity level, the typical type of task they work on is, if you're like in basic, we typically start working with customers in standardized, a basic implementation where you perhaps not even have a SCADA system, you have a homegrown system, work in templates. Well, in standardized, then you start to work with automatic reporting for the governmental parts, individual reporting, processes, operations, and alerts. But we typically help our customers move from there to rationalize and even to optimize, where they do root cause analysis and predictive maintenance applications get even more business driven, which is and part they want to move towards. And the reasoning why they do this, as I mentioned, this infrastructure consisting of SCADA systems, for example, these are large critical systems that takes a lot to install. I mean, a SCADA system could take up to 3 years to implement if you want to change it. What we do is we come in on top, we bring it to life, the data inside of it. We can have the installations up and running in a matter of days. We have not to exceed more than weeks. So that's important to our customers, why they want to work with this. The training part, we do in less than a day. We have 1 day for the super user, and part of that day we train the others. So it's easy to get going. It's not like a BI or integration platform where you need specialists and external consultants to get going and work with your data. And the user experience then is much easier. And then, of course, the efficiency and optimization is, of course, critical for them to actually engage in this, but to start leverage from the platform. So to put in as a final slide here, where we help our customers is, as they're moving from a standardized outset, moving up towards rationalized and optimized and enhancing their operations. We're helping them remove the burden from the reports, getting in more sensors, more data, and bring it to life. They can include more IoT sensors, like Kalle will talk about in Sigfox, and where we see more sensors generating data into your operations, and we're one way to get value from that. So thank you all, and yes, you can get data to talk.
Great, thank you, Gustaf. You were a little bit long, so we only have time for, if you have 1 or 2 questions, we can take those. Please put them on chat if you have a question.
Sure.
I have a question for you while we're waiting to see. So what is typically the time to adopt your solution into a new kind of plant, water plant or something like that? What kind of time? Are we talking weeks or years or?
Typically, I mean, the practical installation is a matter of days. We're yet to exceed 40 hours a man week. I mean, typically the environments where we install into are highly classified from security point of view. So getting access to that and the practical parts with the IT to be able to install our software, that's more a practical issue rather than it takes time. So it's a matter of days.
Okay. And what about, there's a quite generic tool. So what about going to an adjacent kind of industry? Is that very difficult for you, or is it more like that you don't understand that kind of infrastructure or environment, or is it quite easy? Or
it's quite easy. I mean, as you could see, we have a lot of customers in the water industry, but we are seeing more, and we are engaged in corporations like Fleet, for example, who are working with a different type of sensor, the thermal cameras. We're also seeing interest from other types of industry where they have lots of data. They also have data in different time formats, which is an issue to them, and they can't sort of see it in the same view. So that's something we're moving towards, whether it's large vehicles or other process industries. We're having interest in there as well.
Excellent. We have to stop there, Gustaf. Thank you so much. Please unshare your screen. And then we're going to move forward to our next speaker, who is Sebastian Haglund Gaidi, CEO and founder of Greenlytics. Have you unshared, Gustaf? Oh, yeah. There you go. Perfect.
Yeah. Thank you so much.
Good to see you.
Yes. Should I share my screen now?
Yeah, please do.
Great.
And then take it away. I can see you are in the video studio at Things.
Exactly. I'm still holding the fort here, the castle at Things Strong. So yes. Okay. As Magnus said, I'm the CEO and co-founder of Greenlytics. We are a weather analytics startup targeting the power and utility industry. And really, it started like this. So I was working in my previous life, or my previous job at least, in a big utility company in Sweden as a power trader. And as a power trader, you kind of bombard with vast amount of data from the power market, from all the assets that you have, and from weather data. And your job is to kind of to digest all this information and to drive decisions, actionable decisions at speed. And that's of course challenging for any human. And especially, as I said, with weather data, with the advent of more and more, the introduction of more and more renewables into the energy market, this system becomes highly weather dependent and uncertain of weather events. And this is really the challenge that we want to help tackle with Greenlytics using weather analytics. And I put here human operator, because this is not only power traders that have this issue, but also other types of operators dealing with business processes that are weather dependent, such as, for example, district heating or other water industries. As well as more and more control is happening in the future of the energy system on the demand side, these kind of decisions and analysis needs also to become automated and happen locally at the demand side. So that's also something that we're looking into. So what we're doing at Greenlytics is we're combining three fields that we have seen have been quite siloed in many organizations. And that's the knowledge about the weather, the meteorology, the knowledge about the data science and all the data analytics, as well as kind of the business expertise and engineering expertise about the energy system. So that's what we want to help to kind of bring closer together with our customers. And what this boils down to is that we have a platform that does one thing really well. So we collect a lot of weather data from a lot of different weather data providers, such as SMHI, etc. And then we collect historical business data from the customers that we have. So this could be historical production from a windmill or a solar plant, or historical outages on the electricity grid due to storm events. And then using these two data sets, we make a mapping using artificial intelligence to create an understanding of how this weather is affecting their business. And then we can use that mapping going forward into the future to provide business impact from the weather, as well as optimize decision support for these customers to streamline operations and reduce the vulnerability of weather events. So here's an example that we worked on. We worked together with ABB in Germany, and they came to us and they said, we have this factory called Buschjäger. They make this kind of fashionable power sockets and switches, and this is located in Ludenscheid in Western Germany. And they decided to install a 1.5 megawatt peak solar plant on the top of the parking lot. They also installed some EV charging, they installed batteries, and they have some ability to some flexibility in the loads of the production schedules of the factory. So this all becomes a quite intricate energy optimization problem. When should you charge the battery? When should I be able to charge the cars? And you want to be able to do this, lowering your electricity bill, lowering the greenhouse gas impact of this factory, as well as increasing the reliability of the whole site. And ABB, they have a tool that they call Optimax to do all this optimization. But what they asked us for is to have a forecast for the power generation of the solar plants so that they can put that into optimization and solve this problem. And that's what we did. So we developed a tool that we call SolarMind to forecast, visualize, and optimize the process of solar power generation. And it works like this. So on the left hand, we digest weather data from both weather models as well as satellite data on cloud. We then process this data using engineering equations as well as machine learning. And then we output a forecast that we can be digestible either for a user interface or through an API. And here I have a video showing this in action. So basically what you do is you set up a site, you input the coordinates of this site, you put in some data such as the capacity, orientation, and tilt. Then you drag and drop some historical data so that we can do the matching and the machine learning tuning of the forecast using your historical plant profile. And then we provide you with the forecast here in the user interface, but it can easily be digestible through an API as well. So what was the result of all this? Well, we managed to reduce the forecasting error, that was the benchmark forecast, by 30%. So it was quite a big improvement, as well as being able to reduce the greenhouse gas emissions on that site by 15% through more self-consumption at the site. So instead of buying brown electricity from the grid. And all this was actually a part of the ABB Industrial AI Accelerator program in Germany that we participated in and won in May 2019. Another project that we've been working on is a project with a different utility company in Sweden. And they trade electricity from windmills. So basically they had some around 80 megawatts of capacity in windmills, and they asked us, can you provide a forecast for these 5 different sites? And that's what we did. So we developed a different tool called WindMind to then forecast, visualize, and do the trading of these windmills. And the result of this project was that we were able to reduce the forecasting error with 7% compared to the current system. And we calculated actually what does this mean in terms of savings for this customer. And we saw that we could save 11% out of this imbalance cost that they had from trading this wind power. So basically, if you're wrong in your predictions on the electricity market, you need to pay a fee for that. And that's the fee that we were able to reduce. So these are 2 examples that we've been working on processes that are weather dependent and that can be improved using weather analytics. But we are now looking into other fields, such as, for example, heat demand, so district heating. How can we optimize district heating for using more tailored temperature forecast? Or in the water industry, how can we improve the way we use and treat our water using rainfall forecast, for example? And if you're interested in any of these areas, I would be happy to talk with you after this eBazaar. This is our amazing team consisting out of energy engineers, data scientists, and meteorologists. We're at Things, a Things company, and we're located at KTH here. We have a lot of collaboration with KTH and the PhD students there from. And here you have my contact details, so don't hesitate to reach out. And you also have my LinkedIn profile here to the right. Thank you so much.
Wonderful, Sebastian. I'm sure you can almost hear the applause from out there. Great, thank you so much. We have time for questions. So do we have any questions from the audience? Please put them on the chat. Meanwhile, I can ask you something. So how long have you been going as a company?
Yeah, so we've been going for 2 years with the company. We started off in February 2018. And we've been mainly working on some pilot projects. Now have a paid pilot project in Germany with a big utility company there where we do wind power forecasting. And we're also working in quite close collaboration with ABB, as you see in this presentation.
Okay. Here comes a question from someone I know. What's your business model? Upfront fee and license per site or other?
Good question. So we have a very simple SaaS business model. So what we do is that we charge per forecast per month, basically, on site. So if you have a wind farm, then we count that as a site, and we charge based on how many sites you have for every month. Great.
Any other questions? Well, I have my favorite question left for Sebastian, which is, if you're so good at estimating or figuring out forecasting weather, why can't you help forecast the weather?
This is a great question, and really at Greenlytics we're really not focused on forecasting the weather better. We think that there's great people that's out there, these meteorology institutes that are really good at this, and that's their main job. Our innovation here and our take on it is that we want to forecast weather impact. So we say we don't forecast weather, we forecast business impact. And that's what we're concerned with, because we know that that's what matters for our customers.
Brilliant. Okay, so I think we stop there. Thank you so much, Sebastian.
Thank you so much.
Don't forget to unshare your screen, please.
Yes.
Oh, yeah, there are applause here from Joachim from Sus. He makes the virtual applause on the chat. Great. So to our next speaker is Daniel Spahr, the COO of Stream Analyze. Are you there, Daniel?
Yes, I'm here.
Perfect. Welcome.
I'm loud and clear and everybody can see this. Hi, my name is Daniel Spahr. I'm COO for Stream Analyze. We're a software company providing an AI platform for running and deploying and building any AI model onto any edge device. So rather than streaming all your IoT data up into the cloud and analyzing it there, it allows you to do a lot of your analysis up front and do a lot of the heavy lifting out there on the edge where the data is actually being created. I'll go into detail regarding this, but there are a lot of reasons to do this. One is cost for the cloud, which is fairly expensive. I've been a CIO and paid those bills. There can be security reasons where you don't want your data to actually leave the site, but also latency issues or connectivity issues that might create it where you want to run autonomously. So we provide that platform, allow you to do this. Just to kick off with a few cases that we have, just to whet your appetite. One is here, Volvo Construction Equipment. They have these mining loaders or wheel loaders in the mines, and they break down fairly often, or they break down because they're doing a lot of heavy duty lifting. And they want to be able to predict in advance when these are breaking down. So rather than having operations being stopped and maybe hampering other operations because they're in tight quarters, they wanted to predict in advance when the machines are about to break down. Now, to actually create these autonomous models, it was very cumbersome for them. It took a long time. They would record the data, their analysts would try and find out a good model for this, pass it on to IT to develop the AI model, push this onto the hardware, run a test run again, iterate over this, and it took up to about 2 years to get this onto the actual machine, which was way too slow. So what we did is we came in there, installed our software platform, which is made for the analyst and engineer to develop their own AI models on their own interactively. So now they could speed up this whole development process. And thanks to this, what they could do is predict 10 to 12 hours in advance when the gearbox was about to break down. And this allowed the operator to then make sure that their machine went above ground and could meet up with a technician, and their downtime was minimized. So this is one thing that we did. This is another partner of ours, HMS Networks. They're located out of Halmstad, worldwide in connecting manufacturing factories. So they create these small devices, which are routers or gateways, and they connect different machines with each other. So if you have a machine from ABB or from Siemens, they don't really talk to each other very well, even though they need to do this. But they have a plug-and-play solution for this. But thanks to Industry 4.0, their customers want to say, well, we need to have better monitoring of our machines. We want to be able to push out AI models and understand predictively when they're about to break down as well. You guys are managing all our data. Can you help us out? So we found them, they found us, and we are now rolled out onto their global platform, be installed onto their installed base, allowing their customers to create their own AI models through their customer portal and push onto these hardware devices you see here, allowing them to do the AI analysis close to the machine up front. And this way they can do predictive analysis, they can monitor their machines in a more timely fashion. So this is a little bit what it looks like. So what do we really do? We have an edge analytics platform, and it allows you to build, deploy, and run any AI model, anywhere from mathematical statistical models to machine learning models to deep learning models onto any of your current or existing or future hardware that you have out there. And the reason we can do this is we have a very, very small footprint, so you don't need to come in with additional hardware for this. And it really doesn't require a need for deep programming skills, but made for analysts and engineers. And the reason behind this is we really believe in putting this into the hands of those who understand their machines and their devices, because they're the ones that need to be able to build their models, rather than passing it off to an IT department or external consulting department. So we don't provide models, we provide a platform for building models. But also, and there's a last little picture in my little slideshow on this one, is allows you to deploy and run interactively. So you can push out new models, you can query your hardware devices on the fly. What does this look like? Just to give you a little schematic. So our product is called SA Engine. You would install this onto these devices you see on the left-hand side of the picture. On a chainsaw or on a wheel loader, on a circuit board like you see with HMS, or a ball bearing. Assuming that we have a little bit of processing power and some memory, we can install them there. And then we also install ourselves onto a proprietary cloud, so that would be your cloud, and can even hook up with your big data systems like Kafka or Microsoft Event Hub or something like that. Now, once that's installed, that allows you from the cloud to build and deploy these AI models onto these devices. So you do the analysis on the actual device, pushing up whatever you decide that you want to push up, but normally you get a lot of data reduction this way. So for an example, on the wheel loaders, all the data, all the analysis of when this gearbox was about to break down happened on the actual wheel loader. It sent up an alarm up to the cloud, which now went to the monitoring center saying, hey, there's something that's broken down here. The monitoring center can then ask queries to the actual wheel loader, assuming that you had connectivity, saying what's really going on. But also when you deploy a technician, they can query your device saying what's really happening to the device as you want to go out there and actually fix it, knowing that you have the right spare parts, for instance. So these are a few of these things that you could actually do. And this is how the ecosystem works. So you have our SA engine on the device doing the analysis up front, working in symbiosis with a cloud device as well, but allowing you to do this interactiveness. Obviously, there's more details to this, but I'm not going to go through it here. It's a quicker discussion. So SA Engine, what makes us unique? Because there are a lot of edge things out there. One is our size. We have a small footprint. Our smallest version is 64K. Our largest full-fledged one is 5.2 meg, which is usually very small anyway. It allows you to innovate on the fly, so you can deploy and run, but also ask queries to your hard devices interactively. And that allows you, for instance, to deploy new models that are actually out there in the field rather than have to bring them in-house. It also allows you to empower the analysts, because we believe that they know best on how to build these models rather than have to hand it off and do programming through IT or through an external consulting firm. And doesn't require any additional hardware. And it finally gives you that brain that you want from the simple model, so that where you normally start off, to the more advanced machine learning and deep learning models. And if you have models you've developed, you can piggyback on this. So we usually jokingly say it's like installing Excel. It has all the tools, all the functions. We come with over 1,000 functions out of the box. But if you're a CIO, or if you're a controller, you know how to use Excel, but you don't get your P&L models out of the box. But we can help you though. So let's bring this into context with energy. If you have services or assets out there, if it's a house, if it's your production site, or if it's one of these power boxes that you have on your final mile on the grid, installing SA Engine close to these allows you, or on these, allows you to do a few things. One is monitoring. So it allows you to give insights, what's happening on my actual site or onto my devices happening out there. So it'll monitor and it'll be able to upload that data. Secondly, it allows you to push out and create new services for optimizing and improving how they perform. So pushing out a new service or a calculation that you need, adding new features to your existing production site or to your housing, this allows you to do that. And the third, and this is maybe where a lot of people start off working with us, is predicting when things are about to break down. How are things behaving, and how do we actually predict that and create a service around that to allow you to provide better services to your end customers. But even automating, we had one discussion with a manufacturing company for pulp and paper, had 20,000 sensors. They wanted to be able to use that to control things when it's about to break down. Finally, I want to take that power box there and put it into context of a case that we have. And this is something that might be interesting for you if you're in a utility company. The distribution to the power box is what you see out in the road that does the distribution of the last mile to normally a housing area or a large area complex house, and it's found in the streets. Many times the utility companies have very little knowledge of what's happening in that last mile of their network, where you get power surges, power outages, unmonitored power consumption, and this drives cost and maintenance because you can't predict your production in a good way and make sure that things are working the way you want it to do. We are partnered with a company called BE Energy, and they have a little product that's called a smart grid interface module that you actually install into these power boxes. They are plug and play out of the box, and it allows you to understand the last mile of your grid, because what happens is when you have this installed, it now allows you to start pushing up data on what is happening to from that power box and outward into the cloud. Now, so what does our partnership look like? We install SA Engine onto their device that they install, plug and play into these power boxes, but also onto their cloud. And that allows them to now push out monitoring models or AI models that can determine when things are happening into your last mile of your grid. This allows service managers and technicians also to query the grid to see what is really happening. But it could be, for instance, to be able to determine, we have now hooked up a car. So you can take a model for the power surge for a new car that's being hooked up to the grid. And for instance, we've been working with them in Germany. There you don't want to be able to hook up cars anywhere you want because they drive so much consumption that would allow you to actually monitor that, okay, this is something here, an unmonitored electrical car has been connected to the grid. So this is one offering that we have to the utilities area that we believe in that is going to be really interesting long term. So our only question to you now that I have is, why not?
Great, Daniel. Thank you so much. Let's see if we have any questions for you on the chat. No, not really. So let me ask you a question. I actually know the answer, but I'll ask you anyway. So is this something you have pulled together the last 6 months, or is it something you've been working on for long?
No, we've been probably working with this for over 30 years, I would say. It's based off of the development and research from one of our founders, Toivonen, who's a professor emeritus from Uppsala and Linköping University. But our company, Stream Analyze, was founded about 4.5 years ago, where we took his research, productized that, and then since about 2 years back, have gone to the market and seen a lot of success, knowing that edge analytics is here to stay.
Great. So let's see if we have any other questions. So which you covered many things. So which markets are you focusing on?
We focus on 3 markets primarily. One is manufacturing in general, or the heavy industry, if you would say. And the sort of the partnership we see with HMS Networks is an obvious cog in that wheel. The other area that we see as well is automotive. So cars are producing more and more sensor data. We've been talking to Volkswagen. They say their cars will shortly be producing about 4 terabytes of data per car and day. And to push all that up into the cloud, knowing the latency and also the connectivity that you have is not going to work. So they want to be able to do analysis of all that data onto the car. And third is obviously what we're talking about here, the utilities arena, where it comes anywhere from assets to production, the final mile that we're looking at the grid. That's 2 obvious areas we've been addressing so far.
Okay, well, we have to stop there, Daniel. Thank you so much.
Thanks very much.
Don't forget to unshare your screen. Excellent. So to our next speaker, it's Rasmus Toivonen from Logical Clocks. Are you there, Rasmus?
Yeah, I'm here. Thank you.
Excellent. And just share your screen and get going.
Yeah. Let's see. Let's do it like this.
Perfect. I see you.
There we go. So I'm Rasmus Toivonen from Logical Clocks is the company name, and our product, what we offer is Hopsworks. So, and I'm head of machine learning solutions. I'm responsible for the Nordics and the States, and also UK actually. So what is HopsWorks? HopsWorks is basically a full platform for doing data-intensive AI. So thank you for the previous presentation, all of the previous presentations, but especially Daniel from Stream Analytics. I hope we can talk later on. Very interesting. So to represent it the most like a general way is like this. So you have your data sources, and then you have a black box. Where we want you to use HopsWorks. And then you have your applications, your dashboards, or you use our API, the HopsWorks API to call your productionalized models to get your predictions. And so what is HopsWorks? So it's actually a full stack end-to-end platform. And some companies use it as the end-to-end platform, and some others use parts of it and integrate it with the other solutions as well. Because if you're into artificial intelligence, you know that you have to have a lot of services working together, sending data between them. And we have some unique features within our platform. We actually even one very important one is our feature store solution. We'll come to that later. This is just an overview to kind of highlight some of our unique features. And feature store is kind of like a data warehouse for ML feature data, very important one, kind of bridging the gap between the data engineering or feature engineering department and data scientists with data warehouse capabilities. And then we have distributed deep learning, which we were very early in supporting, and we have continued to develop on that. So distributed compute is a big part of our full stack platform. And also we have HopsFS, which is actually our own IP, kind of like Daniel presented. We have a long history of developing our own file system, actually. So this stands for Hops File System. It's our own IP, which is most of it is open source, but implemented in a full stack platform like this. That is only our platform that has it. And we have something called secure multi-tenancy, and that's basically, if you want to describe really quickly and shortly, it's basically a Dropbox-like feature or capability for your data sets between your teams or projects or users on the same hardware. So if you have data sets that are that contains very sensitive data, you can store them on your machine, and you can, even between projects, you can share data sets securely on the same hardware. So you don't have to set up a new hardware for a new set of sensitive data. And this is a management team. We're actually more than 20 people now. And we have got some recognition. We got chosen as the Technology Innovation of the Year for the Data Science Awards in Europe late 2019, and also top 50 by TechCrunch called Digital Top 50. We won an AI Startup Battle, and we've also, for our file system, which is like a core component of our platform, we won some benchmark challenges as well. And this is some bragging. We were the world's first platform to support GPUs as a resource. So that's basically mean distributed GPUs as a resource, file system on NVMe disks. And we were the first open source feature store for machine learning, and we're still the kind of only feature store that is available to the market for enterprises at least. And some other bragging as well. And some of our solutions, or the solutions that our customers have done is, we have Swedbank is one case, and one very relevant nowadays is the anti-money laundering case, where they've utilized deep learning to identify financial transactions as potentially fraudulent or not, or AML or not. And then they have a very huge amount of people that look into them even more, and then they send them to the the fraudulent inspections, Finansinspektionen in Swedish, and to the police to say, okay, we've actually seen that these are potentially fraudulent or not, so you should investigate. They started evaluating this actually before they made the news, so to speak, on this topic, but they are now heading into production with it. So very, very interesting. You can search for Swedbank Talk at Spark Summit, which is basically one of the biggest AI summits in the world, most prominent, where they gave a talk on the topic. We also have the same with automotive industry, and they here it was basically to have a secure data lake where they could share data sets securely to third-party vendors. That's one, and then we have healthcare. So why these industries and also actually utilities? It's because a lot of them has sensitive data and they want to utilize the same hardware for sharing sensitive data sets. That's one part. And the other is that they want to be able to use the latest technologies on their own hardware. And basically the competitors we have most only focus on the cloud, like the American one is focused on the cloud, and European enterprises need to be able to control their data, and they can't put sensitive data on the American cloud vendors, even if they promise that they will store the data only in Europe and so forth. So that's one use case, and it's also very important in healthcare industry, and also insurance, of course, banking, and finance, and also actually in utilities, of course. So why HopsWorks? Why do we exist, and what's our idea? So this is actually, many of you are familiar with artificial intelligence and machine learning, and this is a very famous representation of how does the managing of a deep learning or machine learning platform actually look from sourcing data to actually serving a model. And the middle representation is the actual kind of data science where you actually experiment on a model and train a model, and you get you're able to predict. Then you need to kind of take care of the hardware management, feature engineering, data collection, data validation. If you're an enterprise with large quantities of data, you need to support distribution, hyperparameter tuning, pipeline management, model serving, A/B testing, and monitoring. And so basically, we kind of made an abstraction layer, which we call a feature store, or it's actually commonly called a feature store, but we kind of, we call it HopsWorks feature store. That's our take on it, which you can call as an API in its own, or within the HopsWorks platform as well. So we kind of make this easier for the users. So this one you recognize from before, and I'm just gonna keep on going through these because they are more in detail going on. So this is our platform can actually act as a data lake on its own. The file system that we use is a very efficient one, and some use it only for the data warehousing part and data lake capabilities. But we've added on top a lot of features as well. And this is a very important one, where we actually support pip installation and Conda environments, even on-premise deployments. That's important for the data scientists to be able to use the libraries and frameworks that they are used to develop on, even on-premise installation and air-gapped environments. If you're a data scientist or a data engineer, you're used to using different frameworks and tools to be able to be efficient. And of course, the cloud vendors support that. and now I'm referring to our on-premise offering, but we also have a cloud offering as well. This is good to know, and everything is encrypted. All the calls between all these services are encrypted and so forth, and that's also a unique take on the platform solutions. So I'm going to walk through kind of a machine learning life cycle. So most of the times, data engineering, they source data and do feature engineering and store it into a feature store. And this is to introduce kind of the feature store to the ML life cycle. And then you have the data scientists selecting features to train on or experiment, and then they get good candidates. And then in the end, they have a model repository, which they can deploy onto Kubernetes. And then you can also, in our platform, have online application which actually gets online features. If you're interested in that, we can walk you through it later on. And usually in larger AI teams, you're divided into data engineering team and a data science team, where the data scientists basically, they develop the machine learning models, and the data engineering team make sure that there are feature data within, hopefully, a feature store. And our estimation is that you can be much more productive if you have a feature store capability within your ML platform. So this again is what HubSpot is. And key takeaways from this is that why is we hope to provide an efficient feature engineering solution. And also we have an industry standard stack. We're based on open source, and most of our stack is actually open sourced as well. We have an enterprise offering, which includes support, of course, and also the in-motion encryption and some integrations with, if you're using already Databricks or SageMaker or Azure or Google Cloud, then you can actually use only our feature store part and integrate with what you already have, and also use your existing competencies. So since we are using open source tools and supporting most of the frameworks, your data scientists and data engineers can work within languages and frameworks that they're used to. And it integrates with what you already use, or you can use our full stack platform on your own hardware, on your own cloud instances, or in our managed cloud service, actually. So to remember, we are offering a full platform for data intensive AI, and also a feature store, which is basically a data warehouse for ML data. So how do you remember the name HubSpot? What makes beer taste good? And yeah, it just works. So try it yourself on our managed service, hubsworks.ai. It's just to go there. And if you're a Things audience, which you are, and watching this, you get 2 months free for our full featured capabilities. Just email me, sign up, and then you can just email me and say, yeah, I watched your talk at Things, and I'll help you out. So
great. Thank you so much, Rasmus.
Thank you.
Yeah, so let's see if we have any questions. I really like this twist where you really show people that you make money by hanging around with things. So that's a very good play. So do we have any questions from the audience, or? I can ask you. I think you touched on that, but I guess you both work towards kind of partners with the whole or part of your platform, and obviously with the customers. So when you go to customers, do you have any special kind of markets that you are stronger in or more interested in, or are you kind of quite generic?
We're quite generic. Those who actually are mostly interested in us are the biggest companies in the world, because they have quite big teams, and they are finding themselves having inefficiencies between their feature engineering teams and their data science teams. So you can imagine saving interesting features to your internal kind of feature store, or lists where the data scientists should be able to choose the data to use in their models. but quite quickly it actually adds up to thousands of features, and they become obsolete after time. So you need to know which features are being used, which can we delete, and so forth. So you need governance within this, and also actually being able to answer questions like, okay, this model that we put in development or in production and are used is not performing that well now, and a boss or a head of technology or a solution needs to be able to get answers on, okay, why doesn't it perform? How did it look 6 months ago? So actually offer time travel features on feature data within the platform as well, and that's quite unique. And then the encryption part. So we passed very strict security audits and so forth. So the healthcare industry can actually use our platform for doing AI and so forth, and feeling
Final question from me, because I don't receive any. Yeah, here's a question from the audience. What's in your own opinion one of the most obvious areas where a utility can use your services?
So you have the as I think most of you know, but predictive maintenance, and also to be able to predict when a grid line and so forth will fail. That I would say would be one of the main areas.
Okay, great. A final little question. So this is a quite comprehensive platform, and you have worked a couple of years to pull that together, I guess. So can you tell us a little bit about the background?
Yeah, so the research team behind they've been doing research for 10 years, and then so basically the story sounds very similar to Daniel's the previous presentation. So they've been researching on the HOPS file system for 10 years, and then okay, how can we actually make something useful out of this? And for the latest 3 to 5 years, they've been working on the whole software stack. So yeah, and then we started the company 3 years ago.
Excellent. So we have to stop there, Rasmus. Thank you so much. Please don't forget to unshare your screen, because I know Kalle would like to share his screen next. Kalle Eneroth from Sigfox Sweden. Are you there?
Yes, indeed I am.
I'm sorry, I missed the order of speaking a little bit. I'm sorry, I had to keep you waiting. But
I was getting a bit worried, yes.
Yeah. So take it away. Share your screen and get going.
Right, so you can see my screen?
Yes, now.
Excellent. So my name is Kalle Eneroth. I am the CTO of the Swedish and Norwegian, actually, Sigfox operators. What we do at Sigfox is really to build the communication that makes all of this that we have been talking about so far possible. Well, not all of it. It's one part of it, the low power wide area part. We represent the Swedish and Norwegian part of the world's largest IoT dedicated radio network, Sigfox. Now, this is an operator business. So we are really operating a network where you buy subscriptions, basically. And we simply push data from several different types of devices, like this one, for example, over to the customer system on the other end. What is kind of unique with our network is that it is one global network. It really works as one network. So if you put your device and have it communicating somewhere else in the world where you have Sigfox communication, it will end to end provide you with that data without any type of extra roaming charges or configurations needed. It truly works seamlessly as one global network. Now, we do believe that we are playing a really important part in the ongoing IoT revolution, especially when it comes to the smaller pieces of data that needs to be picked up from massive amounts of places. And why do we say this? Well, we have a very powerful solution that is based on 4 pillars, basically. We have an energy efficient solution, which beats anything else that I have seen. It has very low pieces of data. It's maximum 12 bytes. And we are operating on the ISM, the open and license-free ISM bands around the world, meaning that we are not sending that data that often either. But this, on the other hand, means that we can have easily devices that have a battery lifespan of 10 years. So the operational cost, as you understand, will be very, very low for these as well. Now, as I said, we have a global reach. I think we're up to 74 or 75 different countries in the world, and at least 1/3 of those are now fully covered nationally, and it's growing massively. We're also launching satellites for getting satellite coverage, which will also be working with the existing solutions that we have today. Now, there is a simplicity in this as well. We've been talking about plug and play for many years. Well, these days it's just play, basically. You take one of these devices, you have it activated as it comes out of the box, and then you just put it on the wall and it works. So it's very, very simple. Each device has a globally unique identifier. We're not working with IP all the way out to the device, but rather sending the data in other ways. But they are uniquely identified so that you can distinguish them from each other. Now, the fourth one is also that we have extremely low cost. There is no license to the actual chips on these, and there is a massive ecosystem built around these. I mean, you can imagine yourselves. I mean, many of you within the utilities market in Sweden, well, I don't care if it's a global network. Well, maybe you should, because if you decide as a manufacturer of devices to go for Sigfox, for example, as the carrier of your data, then you will overnight have a market of, well, 75 countries overnight where you can sell your devices, meaning that the ecosystem, last time I checked, I think it was like 50 something devices that are commercially available for you communicating over the global Sigfox network. So if you have a problem, if you're searching for some kind of a device to easily pick up the data that you need, in 8 cases of 10, I would say that it already exists. So what we do at Sigfox, basically transporting the data from devices, from some of these, one of these devices in the ecosystem, over to the customer side. Now we're building a carrier grade network, and we're operating this network in each country as Sigfox operators. We have SLAs on these services, and the costs are extremely low for this data communication, which really enables the mass volume type of IoT applications that we have seen a need for quite a long time. Now, I'm not going to talk anymore about the operator side, because the really interesting part is what happens on the partner side, on the right-hand side, where our partners come in and they build solutions around this communication. One of these partners that we work very closely with, and which is also part of our company group, is a company called DigiNav. And what we've been playing around with for the past couple of years is to build pre-packaged solutions for utilities area, for property management, but also other areas. So I've picked up out a couple of these, just go through quickly, but then I'm going to deep dive in one that we are also working tightly together with Gemit, that Gustaf represented earlier today. So, for example, we have climate control, where we can easily put up sensors to look at temperature, relative humidity, carbon dioxide measurements, different types of particles in the air, and we can really make a difference. There are, in many places in the world, regulatory aspects that you need to take into account in different commercial buildings and so on, and we can, at a very, very low cost, very, very good cost efficiency, give some real-time climate data indoors. We can give predictive analysis and actions to be done. These are turnkey solutions, so it's really commercially off the shelf available. And this makes it tremendously interesting to look at from various perspectives. We also have put together an office space utilizations with several different partners, where you can look at how well our office space is utilized. We're talking about conference rooms, we're talking about seats, what seats are available today. You can easily go to them, you can check in and check out, and you can really optimize the use of your resources when it comes to facilities. Another really interesting aspect these days is of course, energy optimization. there is a lot of work going into optimizing the energy. And one of the aspects is, of course, tightly connected to the indoor climate, meaning temperature specifically. And if you can look at that, we have some really interesting work going on with some utilities companies here in the north, where we're taking the microclimate outside of a building through a local weather station that we've installed, communicating over Sigfox in this case, then measuring the indoor temperature at 60 different places in 60 different apartments and rooms, measuring this data and looking at how does the outside weather impact the energy, the need of energy to be transmitted to the building in order to maintain a good climate, so that you could actually do some predictive energy consumptions and get some predictive control. You get, you can see and measure residents' behavior and so on. And we've seen over time with these solutions that you could actually cut your peak power requirements with 10 to 20%, and on average also lower the consumption by 11% by simply just putting up some sensors and having that data being analyzed and then optimize the energy going into the buildings. Another really interesting part, I mean, I've been reflecting now in these very troublesome times with Corona. I've been seeing with fear how people start just harvesting toilet paper out of all things in Sweden. What happens when people stop doing that and start worrying about what happens if the TV is not turned on, if I don't have any electricity? What happens if my water tap does not give me water when I turn it on? I mean, these are things that we should really be worried about as well. Now, of course, obviously, the utilities just to make sure that this will never happen. But there is an opportunity here to really do some interesting stuff. When it comes to water, fresh water specifically, the World Health Organization has concluded that it's really not uncommon that up to 50% of loss is found in the produced fresh water in urban distribution systems. And here in Sweden, that's really not, we're not an exception to that. The municipals that I've been talking to are saying, yeah, 30 to 40% is really not uncommon. And the problem is that they don't know where these leaks are. They are operating completely blind. So by simply putting a small CAMStrip Sigfox enabled water meter on one end on the pump station going out to a building, and then one on the building side, you can actually measure how much water leaves the pump station and how much actually ends up at the receiving part. Then you do that at all of the different receiving parts, and you can measure, you can calculate a leakage per meter, because you usually know how long the lines are, and thereby giving the operational part of your organization a fair chance to actually find the leaks or do some intelligent analysis. Thereby, of course, optimizing the scarce resources that we have, so that you can really focus the skilled technicians that you have out there in fixing the problems, not blindly searching for them. Then finally, I want to dig a little bit deeper into one case that we've been working with quite successfully and with a very good cooperation of Gemit using their analytics tools. And that's a Legionella guard system. This is a global problem. We've seen in Sweden alone that just for over the past 10 years, the Legionella outbreaks have doubled. And also, and when we have Legionella outbreaks, it's kind of tricky, because if you get that far that you actually end up into the problem, there are, of course, things that you can do, but they are usually quite expensive. You can do thermic water disinfection, ultraviolet disinfection, and other things. However, in worst case, if you can't cope with it on these levels, the worst case scenario is that you might even have to just replace the entire infrastructure in the building. What we need to do is to become proactive. And if you look at the CDC in the US, they have concluded that 9 out of 10 of these outbreaks could actually be avoided if you just have proper control over the water systems. So you could easily then avoid high costs due to litigations, loss of existing and future business, loss in brand, PR, and everything, public trust. We've all read about these bathhouses in several places in Sweden over the past years that has done this, and they are really, it's tough for them to recover from these. So what we do, just for fun, I love these things when you get to dig into new problems and their solutions. The important things to look at in your water mains is two things. It's the temperature of the water that goes through the lines, and that is that there are certain intervals where the risk of Legionella growth is higher. So you want to try to avoid those to the utmost. But then also the other thing is that you want to make sure that you have a flow in the pipes so that the water does not stand still. And these two things are really important. And luckily, they are very easy to measure as well. So by simply using a sensor that is non-invasive, meaning that you just put a clamp on top of the pipe outside, so anyone can install this, you can measure these both things, and you can then get a lot of values out of this. You can get the historical data of the performance and just to see how has it been over the past period of time. You can see the water flow. You can get event-based alarms when you're getting into these dangerous temperature zones, but also if you see that the water flow in the mains are not doing what they should. There are also other things that you can detect from this. You could over time also get a profile over the usage of water in this particular building and have a look at any deviations from this. Meaning, for example, that you could see leakage by just monitoring the potential deviations that go away from these calculated profiles. And the solution is super simple. We really just put a couple of sensors in various places in the building. Like I said, non-invasive, anyone can do this. They are really, not even plug and play, it's just play. You just place them there and then they start communicating over the national Sigfox network in this case. Then we have the data going through the Sigfox network over into, in this case, the Gemit solution where we generate reports, we generate alerts via SMS or emails, and we have dashboards where you can see how your building is performing. So a little bit of getting closer to the actual problems that we aim to fix with our IoT solutions. And yeah, that's what I have with me.
Wonderful. Thank you so much, Kalle. And you're right on time, so we're doing very well. So do we have a question or two? I responded to some questions on the chat, but there might be others. Maybe not. Okay, so I think we'll leave it with that, Kalle. Thank you so much. Absolutely. And as I told you before, you will all get the speakers' addresses afterwards to reach out to them. Thank you so much. And our next and final speaker is Stefan Lindgren from TalkPool. Are you there?
Yes. Do you hear me?
Yeah, we hear you. We would like to see your slides as well. Then we are happy. There you go.
Perfect. Let's put it on. So, yeah, my name is Stefan Lindgren, and I'm the CTO of TalkPool. And I will go through a little bit what we are doing and so on. But first, something about the company. So we are been around since year 2000. We're a listed company on NASDAQ, and we're doing building all kind of infrastructure in different regions of the world. We're doing IT solutions where we both design and we operate the solutions, and we also develop products. So we design development. The IoT core center is here in Sweden, and we've been working with LoRa technology and running LoRa networks since 2016. So about 1/3 of our revenue are out of Europe, 1/3 from the Central America, and 1/3 from the Middle East, Africa region. On the IoT part, these are some of our key customers. So it's a lot around the real estate companies, some cities, some construction companies, and some industrial. And looking at the kind of business verticals that are of interest, it makes sense, since the smart buildings are our most important part, which I will focus on my talk here today, but we're also involved in smart industries and smart cities. So compared to the other presenters so far, we are mainly focused on the bottom layer here. So we are focusing on the sensors and meters that connects to the physical world and bring up the data in order for all the other clever guys that have been on the eBazaar here can do the analytics and all the beauty of it. So we are very much focused on the hardware, on the communication, and so on. And within smart buildings, our main focus are that we're working with energy savings. It can be heating or cooling optimizations of buildings, where we are putting in the sensors that we develop and produce, but also sometimes the third-party sensors, in order to optimize the ventilation in a building to reduce energy. I will go more into detail of that. It can be district heating optimizations, where the energy demand in the buildings are measured, so you know how much energy is needed for the district heatings, and that you can start adding energy to the core of the building before you know that there will be a big dip in temperature outside, in order to avoid the peak powers. We're very much into air quality measurements, both that is part of the, when we do the energy savings, the air quality improvements are coming with it, since we are optimizing on carbon dioxide in most buildings, but we're also doing measurements with particles and so on. We are involved in a few research programs as well on the air and water quality. So also the environmental part is an important part of that. We're doing building automation, which is mainly, should be a big interest of the audience here. So we're doing the building automation of water, electricity, and gas, both for the real estate companies, where we're doing the sub-metering for the companies in order to do the invoicing to the individual tenants, but also for utility companies to measure the water consumptions to buildings or households here. We're also having quite a lot of small meters that is very suitable for individual measurement and invoicing, for example, the BRF or for multi-tenant buildings. One reason in order to do the building automation and to measure all the consumption, that is to doing green building certification. So our meters and sensors are collecting data, and we have integrated it towards the green building certification, if it's a LEED certification or BREEAM or any of the regional certification programs. So the data is, so you know exactly the consumption, but also the air quality and everything that you need for certifying the buildings. And the last part there is damage prevention, where we are working with insurance companies and Anticimex and others in order to prevent damages. It can be risks for mold in basements or in attics. It can be water damages, and we're also having this as part of the that we're building in the sensors into the buildings here. For example, we launched a quite big program with the NCC recently. And when it comes to air quality, it's a lot of the measurements of the carbon dioxide, which is a good indicator for ventilation, for how many people there is in a building. And this is a product that we developed together with Sensair, which is a Swedish world-leading sensor manufacturer. So usually we like the position where we can add our experience of radio and mass volume production and connectivity, and combine it with different companies' expertise, for example, in the Sensair part about carbon dioxide sensors. When it comes to particles, we are measuring the small particles, typical that is part of smog or from traffic. And we are combining that with mechanical filter conditions, so we know when to change the mechanical filters. It can also be, this is especially interest in the Middle East region, and where you have heavy traffic, to see combining it with air purifiers to see that they are actually working as intended. Many of the air quality sensors we are integrating with existing ventilation system, HVAC system. So you can do real-time optimization of the building, to making sure that both you're having a building that is optimal for the people in the building, making sure that you're not wasting energy or having unnecessary carbon dioxide emissions from the building, and also making sure that you are within the regulatory levels of different gases, etc. And one specific business case that I can share, that is what we've done with the Klöven. This is a fairly small and older building in Nyköping. It's 12,000 square meters. It has a rent of 19 million SEK and an energy cost of 75,000 SEK here. What we did there is that we're adding 70 carbon dioxide sensors in the building. We integrated with the existing ventilation system. And by optimizing this, the performance, we're getting an 8% reduction of the power or of the energy cost. And this was for this year. And with the additional tuning, and also when we think that there will be higher energy consumption if it's a more stronger winter, then we're expecting even more energy reduction. Another business case that is building automation and green building certification, in this case a BREEAM certification, and that we are doing for Atrium Ljungberg. And if we're taking one of their areas, they are running a lot of commercial districts, like big malls with many buildings, often old industrial buildings that has been redone into commercial areas. This one is in Sickla, just south of southern part of Stockholm. It's an old industrial area built for Atlas Copco from the very beginning. So it has 78,000 square meters, 168 tenants, and a revenue of 323 millions. And they were doing building automation, so we are measuring all the consumptions of electricity, energy, water, hot water, and then we are doing the green building certification. And the approximate cost for this is 250,000 per year. And by doing the green building certification, that they can reduce the financial cost of the green bonds with 0.25%, and with the loan that is about 3.7 million SEK per year that they are gaining. And in the bottom you can see this data is also fed into the annual reports. So this is from the annual report and sustainability report, where they are both showing how the energy are used in the buildings, how many green leasing deals that they have with their tenants, and they have an ambition that they will reach that 50% of all tenant agreement should be green, so the tenant know exactly what energy they are consuming, and there are some certain conditions in order to classify that as greens, and also to reduce the energy consumption every year here. And so the TalkPool offerings here, it is either that we're doing that we're having a number of smart building solutions that is kind of end-to-end and key ready, that we could be interest for both the utility companies, but also for building companies to take. People that are doing integrations and so on, we're having many different wireless sensors and meters that we are selling that can be connected to any kind of LoRa network. Or we are interested to be a design partner for you, where our experience of providing wireless solutions, we're having an extensive experience of radio and security designs on hardware, as well as low power designs, and for mass volume production here. And as an example, for example, with Sensair, we're developed two products together, where we have provided the radio and electronics and communication parts. They have provided with their connectivity or their carbon dioxide expertise. Our electronics and stack are included in a few different metering applications. B-meters is one of the clients where we are developing and producing the smartness to their mechanical meter. So the data is available out in the cloud. Together with the insurance companies Folksam and Turus, who is a drain manufacturer, we are now launching a product where we have connected measurement of water leakages around the drain, which is one of the major costs for the insurance companies, and where we are providing the sensing and the communication parts for that solution. So if you want to get started, so please contact me. You have my contact data here, and it will be shared as well.
Thank you so much, Stefan. It's amazing to see what happened since 10 years ago when everything was IoT, and how you come in all the way into this nitty-gritty buildings now. It's impressive. I have a question for you from the audience. What radio interface technology is supported? I guess. So
we are focusing on supporting LoRa technology. So it is an spectrum. It's running in the ISM band, and it's widely used both by real estate companies, but also for cities and so on. We are also providing a nationwide LoRa network in Sweden and Denmark, where we have full coverage of the greater part of Stockholm, Gothenburg, Malmö, Uppsala, and about 12 cities that is partially covered. but there is also open standards. So, for example, Stadshussalliansen are running a few cities where usually the energy company or the wireless communication partner are offering IoT connectivity, and also some real estate companies are adding own connectivity to their buildings. So it's a very flexible way to deploy it. And one of the beauty with it is that it is an open ecosystem. And when a company has taken the big investment in sensors and in devices, that they know that they can continue running it as long as it makes economical sense for them. So there is no lock-in effects in it.
Excellent. We have to stop there, Stefan. Thank you so much. And to all the speakers, I really would like to thank you. You are doing incredibly well, as always. It's such a pleasure to be working with you. And to all the audience, thank you so much for spending the time with us. I hope you learned something or a lot, and that you enjoyed listening to those inspiring presentations. And I really hope there will be a follow-on with some of the companies and so forth. And I think you can always hang around and get to know more and more interesting companies, you know, depending on what you look for. You also probably have heard that I always say that startups are to be considered children of industries, and as grown-up industries have a responsibility to the children of their industries. And I think spending time with our presenters here today is a typically very good way of spending time with people, the children of the industry, and hopefully help them to grow up faster than we were planning to do before. So without any further ado, we're going to send out a mail to you as a follow-up, and we will ask you for feedback. And with that, thank you so much.